Well, good day. I just wanted to go ahead and work through the Chapter 7 practice homework. Just going to do a quick check to make sure I'm sharing the correct screen, and I am. So I'm in module 7.5, and I'm going to load this practice homework and do a recording, and then I'll post the recording out here as well. But so the 7A practice homework is a little bit interesting because it has kind of these questions about how do we understand service operations and waiting time and lines and kind of how can we quantify what's happening with those lines. So the problem that we have is students arrive at the administrative services office at an average of 1 every 15 minutes, and their request takes on average 10 minutes to be processed. The service counter is staffed by only one clerk, Judy Gumshoes, who works 8 hours per day. Assume Poisson arrivals and exponential service times. Okay, and so we'll discuss Poisson arrivals and exponential service times in the lecture. But what we're going to do is we're going to use a spreadsheet to help us figure out the answers to these questions. So what I want to do is I'm going to go ahead and open up. Let me just do it like this. So my spreadsheet is going to be in the Chapter 7 modules. Right, so when I go to Chapter 7, boom, under review additional learning activities, I think, let's see, or it's nope, let's try the next one. Practice what you learned. Okay, here's this Excel file, and it may be prettied up when you see it. I may get the button to look correct, but basically you want to download this Excel file. Okay, and I'm going to save that to my desktop just for now. And open it. Boom. And so I have that open. So we'll put it here and we'll come back to this. All right. So from the lecture, what you should have recalled is that basically when we're talking about service times, we're really talking about to understand what's happening in waiting lines and the length of waiting lines, we need a couple of key pieces of information. And one of them is what's called lambda, which is the arrival rate, and the other one is mu, which is the average service rate, okay? And so in this particular example, we've got that a customer arrives every 15 minutes and their requests take on average 10 minutes to be processed, okay? So the service counter is staffed by only one clerk and she works 8 hours a day, which at this point is not really relevant. What I need to get from that is that my lambda, my arrival rate, right, is 1 every 15 minutes, which means that I get 4. Oops, I have to enable editing. I'm like, why isn't that working? So that's going to be 4 per hour. And I'm just using from this this example 1 so we can look at how this change, what our statistics actually are. So then the average service time is, what do we say, 10 minutes to be processed, which means that I can process 6 in an hour. Okay. And so what I can get from that is I can say, well, how much time is Judy, who's our service person, how much time is she idle? Okay, so if I look over here, I can say, here's my interval arrival time, here's my service time. The system is utilized 66.7% of the time, which then means that it would not be utilized 33.3%. So, and this is rho, right? P, the service utilization is rho. So percentage of time that she's idle is 1 minus rho, okay? How much time on average does a student spend waiting in line? So, okay, if we look, we've got the average number in line is L sub Q. The average number in the system is L sub S. The average time in line is W sub Q. And the average time in the system is W sub S. So what we're looking at here, how much time does a student spend waiting in line? So average time in line, 0.333. And we have to remember we're of an hour. So 1/3 of an hour is 20 minutes, okay? How long is the waiting line on average? Okay, the average length of the waiting line. So average number in line, L sub Q 1.33. Okay, this one is just a little bit trickier, but it's still very doable. What's the probability that an arriving student just before entering the administrative service office will find at least one person waiting in line? Okay, so the thing that's tricky about that is you've got one person in line and you're going to be the second person in line. So now we're going to say 2. Okay, and this says, we have to read this correctly. This is the probability that you're going to find more than 2 people in the system is 55.56%. So the fact that I'm going to find less than 2 people in the entire system would be 44.4%, or 1 minus this probability. Okay, so I'm going to encourage you to use this spreadsheet. You can follow along as long as you know rho, as long as you know lambda and mu, and you can use these equations, right? But we have this spreadsheet that makes life pretty handy for us, and we can walk through that and figure these out, right? So the key things are to make sure that you know that lambda is arrival rate, mu is the service rate, and rho is the system utilization rate. So those are kind of the variables. Make sure you get comfortable with what these variables are. But that's really it for the Chapter 7 homework.